Okay, got my Stanley battery charger here. This unit's a 40 amp charger, and it has a voltage and amp display. I have to switch between them as we charge up. Right now it's telling me to connect the battery leads, and I have one connected to the negative. I have the positive in my hand, and as I connect, now it no longer says connect a battery, and I can push the charge button. I'm going to actually turn this overhead light off, see if that helps our visual anyway. And when I hit the charge, I do have to switch back and forth. We'll get a 12.9 volts. I'm going to go and turn the charge off real quick, see what the voltage reads. So it started putting voltage in it. Remember, the computer said it was 11.75-ish. So already it's put a small amount of voltage into this thing. So I have to switch back and forth basically to see what the voltage is. So I'm going to go ahead and push charge. Again, go back there, hit charge. There's my current. Now it's a 40 amp capacity charger, so it jumps up to 40 amps. The voltage started at 12 and will continue to climb from 12 all the way to 14.7. So right now it's 13.3. In a minute we'll probably see 13.4. For the entire duration of the charge cycle until it gets to 14.7, this charger will be putting out max current, max charging capacity of 40.9 amps. So we'll let this sit here for a minute, and I will come back. Now I anticipate, since we took approximately 40 amp hours out of the battery, it'll take approximately 40 amp hours into the battery, and we're going at 40 amps, so that's roughly 1 hour. All that doesn't take into effect charging efficiency, so this may take a couple iterations of videos. Okay, so it's been about 15 minutes or so. I let this sit, and as you can see, the voltage has come up to 13.9, and I'll go back, and the amperage is still 40.9, and we'll come back another 15 minutes or so. Okay, so you can see we're already up. We're up to 14.4. We're still at max capacity. Now, we are putting a tremendous amount of power into this battery, so it's a good idea to monitor the temperature. Some higher quality marine application chargers actually have a temperature sensor that you attach to the battery. This is really more of a benchtop charger, so not really intended to be any sort of permanent installation. But I'm putting my hand back here on the charger, and it is comfortable. It is not cool to touch, but it is not hot either. We're outside probably about 75 degrees or so. So already coming up in voltage, and I will come back in a few minutes trying to get to that 14.7. So I have to apologize. I've been saying 14.7, and for industrial batteries, for marine chargers, for high quality chargers, it is 14.7. You can look it up. It's online. This battery charger is actually designed. They design it so that you can't burn up AGM batteries or gel cells or anything else. So a lot of your alternators, a lot of your automotive applications, they stop at 14.4. Here I was going for 14.7. This one stops at 14.4. So when I switch back to the amps, you can already see that the amps are starting to come down. I kind of wish I'd have been able to catch it when it hit 14.4 so that you could see that. I apologize. But what you will see is these amps continuing to drop while it maintains a battery voltage of 14.4. So it'll stay at 14.4 for the remainder of the charge duration. The period of time that it took to get from 12 volts to 14.4 volts was what is known as the bulk charging phase. It is the first phase of charging a lead-acid battery. It would be easy to think that, oh, my battery is now charged. You could turn the charger off, you would walk away, and you would see voltage precipitously fall all the way down below 12.7. The battery is not actually fully charged. Once it reaches the 14.4 volts, you're approximately 80% charged. You've still got 20% capacity to go. So this part that we're in now, the phase we're in now, is the second phase of charging. It's called the acceptance phase. During the acceptance phase, the speed at which you charge starts going down. You can see that we're only going at 31 amps. So you may have 20% capacity left. In this case, that would be about 16 amps. And you would expect that that would only take if you were going at 40 amps, you would expect that that would take less than half an hour. It would take very little time. But as this process continues, it will slow. It'll go slower and slower and slower and slower. Those amps will just keep going down. So what you'll find is that you may not get to a 100% capacity for 2 or 3 or 4 hours. So we'll continue to watch this as it goes through the acceptance phase, and as you can see, we're already back down. It did just go through a check. The charger does a self-check. Periodically, it will shut off, check the battery voltage, make sure things are going proper, and then restart the charge. So you can see it's still at 14.4 and dropping the current. Back in a few minutes. Okay, it's been about 5 or 10 minutes or so. We're down to 22.1 amps. Something that and I'll go ahead and show you the volts again. It's a 14.5, 14.4, 14.5. Something that I forgot to mention was that the charger has to reduce the current. We're at the point in the charging cycle that if the charger does not reduce the current, the voltage will continue to go up. If the voltage goes above about 14.7 volts, you actually start breaking apart the water more than you break apart the sulfuric or the lead sulfate ions, driving them back into solution. So you end up basically boiling the battery. You end up with a lot more hydrogen and oxygen production. That's going to happen regardless at just about any during any charge cycle. But when there's more lead sulfate to be broke down, that's what breaks down preferentially. When you get to 14.4, 14.5, you have to start lowering the current. Otherwise, the water will start boiling off. So it's not really that the charger is some sort of, smart entity that knows exactly how charged the battery is and it starts lowering the current. It is monitoring the voltage and working to get to that max voltage and then simply maintaining it. And the current is what comes down sympathetically. All right, come back about 15-20 minutes or so. We're down to, actually it's been closer to half an hour, we're down to 10.4 amps and we're still holding out at 14.4, 14.5 volts. So that'll continue to come down. Check back in a little bit, give this battery a feel. She is warm, but not hot. Warmer than ambient, just not hot. And come back in a bit. Okay. It's probably been 20 or 30 minutes now. It's just slowly coming down. You're at 5 amps. I'd like to try to make sure I catch it before it goes to roughly 2 amps. When it goes to 2 amps, the volts, it'll shift. The charger will shift into a float mode. It will be full charged, and the charger will reduce its charge voltage to 13.6. Basically, it'll maintain 13.6 for as long as it has to. that's a float voltage. So I got a 10-minute timer set. I'll come back in 10 minutes, see what happens. Okay, it's a good chance I'm probably going to miss it, but it's been almost 2 hours since we started charging. Now, if we were doing exactly 40 amps for 2 hours, we would have put more than 80, well, we would put roughly 80 amp hours of charge into this battery. We are still not yet out of the acceptance phase. It just dropped down to 2.2 amps. You can see that I'm still holding out at 14.6 volts. Technically, this battery is still not yet fully charged, 100% charged. So in the first hour, in probably the less than the first hour, we got through the bulk phase. We got through the bulk charging phase. It was actually considerably less than the first hour, about a half an hour in, and we had already gotten to the acceptance phase. Now, the acceptance phase has been taking about an hour and a half. That is because you can't charge at the same speed. We've had to slow down. We're only going at 2.2 amps now. So, like I said, I will probably miss it, but this is, I just wanted to get this last chance to grab a low amperage. Okay, I managed to catch it while it was at 2.0, and you'll see that it's still at 14.6. Let's see how low she goes. I was able to catch one more step down. We're at 1.8 amps and still at 14.6 volts. So, one last step, I think. We'll see. Hopefully I catch it on the... Okay, so evidently the very last step in this charger's sequence is just simply to go straight to float mode. So float is indicated there, 13.6 volts, and the battery symbol is no longer showing that it is filling. I don't know if you guys noticed that in the previous show. So what this is basically doing, if I had a separate ammeter, I could actually monitor how much current was going in there. It's very low. Usually between 1 and 2 amps or so. The intention is to not be actually charging the battery. So all it's doing is just maintaining 13.6 volts. If something were to happen, if a load were to be added to it that dragged the battery down while the battery was on, while the battery charger was on, the battery charger would instantaneously detect that and then ramp right back into its charge protocol. It would start trying to maintain 14.4 volts. So any type of load, if you start the car, if you turn on the lights, whatever that is, it's usually more than the float current, and it'll immediately, the charger picks that up and starts trying to charge the battery. At that point, the charger is acting as both a power supply and a charger. It doesn't care where the electricity is going. It just wants to maintain 14.4 volts. There you go. I should also mention that it's taken almost 3 hours, just shy of 3 hours, to complete this charge. The first half hour was the bulk charging. That's the only point at which 40 amps was actually being applied to the battery. Once that half hour was up, once we got to 80%, once the voltage was at 14.4, then the current started being backed off. That was the acceptance phase. Now, the acceptance phase took the better part of the remaining 2.5 hours, 2-ish hours, 2.5 hours. So you can see that when the battery voltage is reading 14.4, it's not full charge. It's still got a long time to go. The better part of 2 or 3 hours left on the charge cycle. And now, as you can see, it's on float. and the float will last. It can sit on float indefinitely. It is the healthy way to maintain a battery. If you got a battery tender, one of those little devices that you get at Walmart, that's what it does. It just maintains a float. All battery chargers, when you plug into shore power, the little 1 amp motorcycle battery chargers, the intent for those is to maintain the battery with at 13.6 volts, a very low, relatively low current. I believe that if I disconnect this battery, the battery charger will go out of, just pulled the cord off, it will go out of float mode. I'll reconnect it. You hear it acknowledge, and now it is no longer in, I don't believe it's in float mode any longer. It is in monitoring mode. So I'll monitor this for a little while. I'll come back, I'll keep checking on the voltage, but what I expect is that the voltage will continue to drift down. We'll watch it just drift down to 12.7. Alright, thanks. Alright, it's been about 8 hours or so since I discontinued to charge, since it went to a float charge. And you can see the voltage is down about 3.3 volts. So we'll keep an eye on it for the next 24 hours. Alright, this is about almost 12 hours, maybe 10 hours after we discontinue the charge. And probably next video will be tomorrow morning, about 10 hours from now.